So in Chapter 8, we are covering a number of things. The first one is processes with extinction. That's when you're going to remove a reinforcer. And then we have some stimulus control I want to talk about. So let's go ahead and let me put up a few slides for this. You should be good, let me see, getting this kind of stuff, the extinction, things that happen with extinction from the book, okay? So these are behaviors, your worksheet, just go ahead and try it. In the answer, I gave you one set of answers. So if you want to post your, on the blog, your examples, post your answers to the Sean and the cell phone thing, and I can get feedback on that. Just use the Charlotte example answer as a template and just come up, all right, so if your cell phone wasn't working, you tried to turn it on, it doesn't turn on, you're on extinction. What would an extinction burst look like? What would variability look like? I mean, what would you do, okay, if your cell phone wasn't working? Just think about it. What would you be doing if you were frustrated or became aggressive or got depressed? What would that look like? That's all you're looking for answers to that worksheet question. Now, after that, were things that make you slow to extinguish, okay? And we had the example on an assignment about what if your favorite restaurant, the chef is different, now it's terrible food. And you had to come up with all these ideas, right? Let me get to that. These factors, you know? So like history of the reinforcer. Well, if you've been going to that restaurant for a really long time, it's gonna take you longer to give up and just say, oh, this is no good anymore. You know, as opposed to you went to it once or twice and now it's terrible, you're gonna be like, I'm not going there anymore. That's how long your learning history, it impacts how quickly you're going to extinguish, okay? So that stuff's pretty straightforward. I think you can get it from the book and work that worksheet. Now, what I want to go back to is this partial reinforcement extinction effect. Your textbook calls it PRE, I believe. But it's just the fact that if behavior is only sometimes reinforced, and then it goes on extinction, the reinforcer is removed, it's going to take actually longer for the animal or the person to extinguish, to stop doing the behavior, compared to if they had been reinforced every single time. If you're reinforced every single time and then the reinforcer goes away, you'll stop more quickly than if you were only sometimes reinforced. Okay, so that's what the partial reinforcement extinction effect is. And most of our behaviors are not reinforced every single time. I mean, every time you order something at a restaurant, it's not great. Every time you try to call your friend, they don't answer. Every time you read a book, it's not going to be the best book ever. Every time you say hello to somebody, you might not get a good reaction, but sometimes we do. So we are on partial reinforcement for pretty much any behavior. I mean, if you have a TV show you watch and every time you watch it, you enjoy it, then you're on continuous reinforcement. And technically, you would be on a fixed ratio 1. Every time you do the behavior, you get the reinforcement. But again, that's actually pretty rare for most of our behaviors. So what I want you to know, and this is not in your textbook, is there's a study that looks at why this is. Now, our initial, answer to why would it be, the common sense answer might be like, well, when you're on continuous reinforcement, so every single time you do the behavior, you get the reinforcer. And then extinction starts, you do the behavior, and you don't get your reinforcer. Well, that's really easy to notice that something is different. But if you only sometimes get reinforced, let's say there's a vending machine that you put the money in, and only sometimes does it actually give you your potato chips. So, you go one day, and this always happens. Sometimes you get them, sometimes you don't. And for some reason, you keep trying. So I go one day, I put my money in, and I'm on partial reinforcement. I'm like, I don't get them today. What if, in reality, I'm on extinction and I'm never going to get those potato chips again? It would be very hard for me to notice that, to know there's a change. Now, here's the thing. What I just described is not the answer to the question, why does partial reinforcement make us slower to extinguish? And here's why we know that. Well, here's the answer. All right, so what you're seeing here, these two lines, are two groups of rats. The top line where it says CRF, extinction. Okay, that group of rats in the first phase of this experiment, they were put on continuous reinforcement. So fixed ratio 1, every time they press their lever, they got a food pellet. Okay, so they're just working, get their food pellet. And in phase 2, that happens again, no change. They're getting their food every time they press a lever. And then the food stops. Okay, they start pressing the lever, no more food, and we see how long do they keep going before they just stop pressing, before they extinguish. Now the second line is a second group of rats. These guys were on some kind of partial reinforcement. So maybe they are on a variable ratio 5. So on average, every 5, times they did it, they get their pellet, but there were plenty of times when they press the lever and they get nothing. Okay, so they do that for a little bit. Now in phase 2, they get continuous reinforcement. Every single time they press their lever, they get food. Now they move to extinction. Now on day 3, we're going to no food no matter what you do with your lever, and they're pressing. And we see how long do they persist before they give up and extinguish. And as you see, these two groups now had the exact same opportunity to notice a change. They moved from continuous reinforcement to no reinforcement, to an extinction phase. So both of them could be like, oh, something's changed, right? But the rats that had this previous experience with only sometimes being reinforced, the PRF, partial reinforcement, they continued to try. They took longer pressing their little levers before they just gave up and said, no, I'm not going to do that anymore, okay? What this tells us, this is important, is that it's not simply a matter of noticing that something's changed, that noticing reinforcement is not coming. Instead, when we have experience only sometimes getting reinforced, it makes us persistent. And when we hit an extinction phase, and the thing about extinction is you don't really know that the reinforcer is never coming back, right? The rat doesn't know that we're never going to give them food again, right? So they keep trying. And same in our lives. We don't really know if we're never going to get that reinforcer back. If somebody, even think about this, if somebody dumps us, we're dating, it's like, oh, it's fine, and oh, you broke up with me, we may persist in trying to still hang out with that person because we don't know if they really are finished with us, or if maybe they'll change their mind and they'll come back and we'll get together. People break up and get back together all the time. How do you know, right? And so we persist, and it's having that experience of still trying that makes us still try when we may actually be on extinction. So we don't give up like that right away. We don't extinguish right away. All right, so hopefully that helps. I do want you to know that concept. And like I said, it's not in the book, so I'm glad you're watching this. Okay, so now we want to go on to, let's see. Well, see the top here where it says learning history. When we persist in the face of non-reinforcement, that sort of tells us to keep going when we don't get what we want. Think about this. This is a very American thing too. It's like try again. Perseverance wins. My old math teacher in high school used to say that. Perseverance wins. And now I think of that's like the partial reinforcement extinction effect. Okay, now one last thing on extinction. If you want to really get a behavior to stop, and you're going to do it by removing the reinforcer, putting it on extinction. So I want my dog to not beg at the table. So I'm going to say, I'm not feeding you anymore. You're on extinction. Of course, he doesn't know what that means. So he'll try for a little bit. But I want him to get stopped sooner. The best thing you can do, give him something else to do. Basically, give him a different way to get reinforcement. So probably the best thing I could do is feed my dog in his bowl in the kitchen while I'm out eating my dinner. And that's going to give him a different way to get food so he's not sitting by the table begging. Now, there's two things. Your book talks about DRO, differential reinforcement of other behavior. Differential means I'm doing something different. So I'm not going to reinforce the behavior I want to extinguish. I am going to reinforce some other replacement behavior. That's the other. Now, if I can, what's even better, this is sort of a special kind of DRO, is a DRI. I'm going to reinforce not only some other behavior, but some other behavior that interferes with the thing I'm trying to get you to stop doing. So you can't do the two things at the same time. So like my dog example, if I can reinforce him for eating in the kitchen, he can't eat in the kitchen and be sitting there and begging at the table at the same time. So that would be a DRI. That's awesome. My example for this too is I used my kids, kid example. You know, they used to do this thing when they're little. You'd be standing there and this kid would come up and go, and they would make this weird noise, and I'd look at them and I'd be like, what? Say that again? Now, at this point, I actually know what they're saying. They're saying, can I have a piece of candy? But I am not going to reinforce that. So, because the whining is this like high-pitched little, it's like nails on a chalkboard. So say it clearly. Let's try that. Candy. Like, okay, you're getting closer. Can you just say it in a normal voice? Say it in a normal voice, just like you're talking. And eventually, it would take 6 or 7 times. They'd say, can I have a piece of candy? And I would say, yes. And what I was doing, I know, learning geek, is I was reinforcing them saying it in a regular, normal voice. And I was not reinforcing this whiny, high-pitched kind of voice, because I didn't want to hear that. But I was okay reinforcing them in, can I have a piece of candy voice? It's like, yes, as long as you speak like that, I will give you candy. That would be DRI, differential reinforcement of an incompatible behavior. You can't speak normally and also be whining at the same time. So there's your example. All right, now let's get to our other topic. Okay, stimulus control. Remember, in operant conditioning, we have a 3-part contingency. We have a stimulus, a response, and then a consequence, which is either going to be a reinforcing stimulus or a punishing stimulus. So we have SRS, okay? Now, we've been talking a lot about the response and the consequence and labeling positive, negative reinforcement, positive, negative punishment. But now we're going to go to this first S at the very beginning. What comes before the behavior, before the response? So, you know, here on my phone, I kind of put those cat things to be funny. Yeah, right. You know, I see a little 2, and I'm like, oh, I'll check my Facebook, right? That's a stimulus that elicits a response from me. I see it, and I hit it, and then I may be rewarded or reinforced by seeing some post that somebody put. Okay, well, here's another one. I'm walking up, you know, with a piece of paper to this bin, and I'm going to put it in the all paper slot because I see the words. I'm like, oh, there we go. It elicits this response from me. This is where I should put it. And then I guess I'm reinforced because I feel good. I just recycled. Okay, so here we are. See the S plus. That's the, you know, first part of our 3-part contingency. It's the thing that gets the behavior started. So the behavior is the R, your response. And then the outcome is, again, a reinforcing or punishing stimulus. So our SR or SP. And your book has a lot of examples, things that make you start your behavior, get you going. You know, when I say, please put your phones away in class, people hear that and hopefully they go, oh, okay, right? You see a green light, you drive. All right. We'll get to those later. All right, so let's look at, I just want to say a little bit about generalization gradients because you have to draw one on one of your worksheets. The S plus is what you're trained on. Okay, so when you hear this, well, here we have an S plus of tones, so rats in a box. And when they hear a certain tone, that tells them reinforcement is available. Go ahead, press your lever. Now, we should get the most lever pressing to the tone that they were trained on. Okay, we should have the highest peak. So look at that one that has the kind of medium dotted line, and it goes right up. The S plus is 1,000 in this graph, and the curve that points, you know, peaks right on that 1,000. That's just, you know, this rat heard this tone, and when that tone was turned on, food was available, and it's a particular note, right? Oh, go get my food. Okay. Now, he's just trained with hearing that one note and having it tied to food. Now, to get a generalization gradient, what I do now is once he's learned it, I start playing other notes, okay, like higher notes, lower notes, and I see what the rat does. Now, obviously, when he hears the one he was trained on, he's going to go press his lever the most. The generalization gradient shows that when he hears things that are similar to that note, he will also press his lever. I mean, if he's trained on, oh, that's food, and then he hears, he's going to go, I don't know what that means. He doesn't do that, right? He goes, oh, I'll go press my lever. Now, as you get notes that are farther and farther and farther away, his lever pressing drops off. Okay, because he starts, we don't know, but I don't know what this is, right? So that's where you get your curve, your generalization gradient. Let's look at these. Here's 3 curves, okay? And they're trained on one note, and then as you test them, now these are actually colors of light. We've switched to pigeons, and on the x-axis, those are different wavelengths of light, so they would be different colors. So I train you on one color, and as I get more and more to the blue-green side of the spectrum or the orange-red side of the spectrum, I get more and more different from what you were trained on. Your behavior drops off. This pigeon, now they peck keys. The number of times they peck the keys are going to drop off. Okay, so that's a generalization gradient. All right, now what we want to look at here is peak shift. Okay, so to get peak shift, we have what's called discrimination training. Now think about this. If you're discriminating, you can tell the difference between things. So on this graph, I don't know if you can see my mouse, but look at the dotted line in the middle that goes up, and it says S+. Okay, and at the top, let's see. So the S+ here is at 550. So look on the x-axis, find 550 where that dotted line just goes up. What that means is when the pigeon saw that color, 550 nanometers, so whatever color that is, when the key was that color, the pigeon pecked it and you got food. Okay, so the S+, now plus tells you you will be reinforced. And S- on the other hand, is something that tells you you're not going to be reinforced for the behavior right now. So if you look at the solid line, that's the pigeon that the only thing he knew or was trained on was when you see this color, you get food. He had no S-, just an S+. You get food when you see this color. Okay. The other pigeons had what we call discrimination training. They got the same S+, they got the same color lighting up their key, and they learned when it's that color, peck on it, you get your food. But they also had other trials, discrimination trials. They were given colors, and if you see, the S- were 555, so a little bit higher on the scale, a little bit different color, and 590, a little bit higher on the scale. To the right of this graph is where the S- were. So what that means is those pigeons, let's look at the guy with the tiniest dotted line, the S- of 590. That pigeon said, when you see this color, you get food. But he had other trials where he said, but if the key is this color, a little bit different, there will not be food. Okay, so this is the 2 kinds of trials he has for a while, and once he's figured it out, now we start testing him on every color on the spectrum, and we graph his responses. So look at that the smallest dotted line for the 590 guy. And what you see here is what color got the most responses? Where's the highest part of his graph? Weirdly, it is not at the S+. It's not at the thing that he was trained that you get food. It has shifted to the left. Okay. Now, good for us, what you just need to think about is he's trying to kind of avoid the color that tells him there will be no food. And in avoiding it, he's actually moved his peak behavior away from the thing that actually tells him there is food. And when we're testing them on these, they're never getting food. We're just seeing how much do you peck if we show you this color, which you've never actually seen before. You've only seen 2. You've seen the get food color and the don't get food color. And I'm just trying other colors, counting how many times you peck the key and graphing it. And look, you're pecking the most to a color you've never seen before and never gives you food. but you're doing it because you're kind of trying to avoid this thing over here. There are two things I want you to know about peak shift and two things you need to know to draw a graph on that worksheet that's posted. First of all, the shift is going to be away. Assume that they're always first going to peak at the S plus. Okay, the peak should be at the S plus. But when we add an S minus, the peak will shift, and it's going to shift away from wherever the S minus is. So I'm trying to match up the graph on your screen. If here's my S plus 550 and my S minus is 590, I should be peaking here, but I'm going to shift away in the direction away from this, that S minus. So I'm going to shift this way. Now, if my S plus was 550, but I had an S minus over here on this side to the left of it on my graph, where would the shift be? It has to be, your default is, well, it should be here, but I'm going to shift in the direction away from the S minus. So if my S minus is over here, I'm going to shift this way. Okay, so the first thing is use your default as the S plus, and then where's the shift? It's in the direction away from wherever your S minus is. Okay, so that's the first thing you have to know in drawing graphs for peak shift. The other thing you have to know is you will have, the closer the S minus is to the S plus, the more shift. So if my S minus is right here, like in here, the 550 guy, he shifts more than the guy whose S minus was way over here at 590. He shifts just a little bit. And there's a really easy analogy to remember that. If you're standing in water and somebody, splashes you, and you're standing right next to me and I splash you, you're going to have a bigger splash than if you were like, 5 yards away and I splash, and you're just going to get this little ripple, right? So the closer those things are, the bigger the push, okay? So when you're drawing your peak shift graph on that handout, the worksheet for Thursday, you're going to draw a couple of, slopey little curves, but you're going to have your peak off of the S plus in the direction away from the S minus, and whichever one is closest, there are two S minuses, or the S minus that's closest to the S plus, it's going to have a bigger shift. Okay, so those are what you need to know to draw those graphs. Now I'm going to show you one last thing. I hope it's one last thing, yeah, about why this is. Okay, I don't know if you can see my mouse here, but what we're showing is, think about it this way. S pluses, things that tell you you will be reinforced or you will be punished, there will be a consequence. We assume those, we call that excitatory learning. So this little dotted line that goes up and down, okay? The top of that dotted line that says excitatory generalization gradient, okay? The top of that line, the peak of that particular gradient, is going to be your S plus. Now we assume that S minuses, you can see the S plus actually on the x-axis here, in the line in the middle is 0. S minuses, we assume, actually inhibit behavior, and they have their own gradient, inhibitory generalization gradient. And the idea, if there's one thing telling me to behave and one thing telling me don't behave because you're not going to get food, these two curves, if you were to take the net result, like kind of combine these curves, you would end up with the solid line curve you see here, which is the actual behavior. This is not unlike opponent process, where we had the A process and the B process, and when they combine, that's the emotion we feel, okay? I always say this kind of concept is something that discriminates my A students from my C students. So if you're getting it, that's great, you're awesome. If you're not getting it, I just want to say it's more detailed than you really need to worry about then, but I do want to make sure you understand those two things about the peak shift graph, as far as the direction it will shift and how far it will shift, just relative to a different, okay. All right, I think I'm gonna, let me make sure, yeah. Well, let me add just this one thing. The whole thing about generalization and discrimination, does come into play when we're learning concepts. Think of Piaget's cognitive development from Psych 110. When we generalize, we're treating things as if they are the same. When we discriminate, we're treating things differently. And this actually kind of maps onto our, normal ways that we use the words generalize, like, oh, you're generalizing. Like, oh, I'll pick any group of people that you want to generalize, or, this is how prejudice happens. Like, oh, you're all the same. All you college students are lazy and don't do your work. Oh. All right, that would be generalizing, right? It'd be like, yo, you're lumping all you together, right? All those. I was in North Carolina over the weekend, and we saw someone over their Confederate flag. I'm like, well, maybe North Carolina. So, and someone's like, not all of us, right? So it's like, that's generalization, when you treat people as if they're all the same. When you discriminate, you're telling the difference, like seeing individual differences, which sounds good, but you actually discriminate, you treat people differently based on, some race or something like that. That's bad, but the words do mean the same thing in this instance: discrimination and generalization. Now, for us, we're trying to tell the difference between stimuli. So, think about somebody who has a very discriminating palate. If somebody is a beer connoisseur and they can tell the difference between a porter and a stout and an IPA and something, they can tell the difference. They're discriminating. Somebody who's like, I don't know, all taste the same to me, I'll just drink my Bud Light, right? Because they can't tell the difference. They're generalizing. They can't tell the difference. So those words do just kind of mean those things. Okay, I'm going to try to stop this video now. It's already long. So hopefully that helped a little bit.